Hello bachcho, good morning to all. I am Sikander sir and today I come with the new topic that is energy. Yes, today we will discuss about energy, and as we know that we have already started the work energy powers, and this is the topic from that ones. Okay, it means this will be the third lecture of work energy and power. Okay, very good. So work energy powers, that means this is the zero third classes work energy and power. Okay, work energy and powers, this is the third class, and in this class first today we discuss about the energy. Yes, energy. You know what is the energy? Energy means what? The capacity of doing work. Whenever we do any works, we need some energy. Okay, because without energy we cannot do our works. And you also know that the energy is a which quantity? A scalar quantity. Very good. And there are so many types. How many types are there? Just like light energy, mechanical energy, electrical energy. Yes. So these are the types of the energy. Okay, the energy is divided in many groups, but you know that the energy whenever we do some works, it is very important. Without energy we cannot do our work. Okay, and we can also find out their dimensional formula, but before it first we will write what is the energy. Energy means you can write these ones. It is the capacity or capacity or ability of doing work is called its energy. Is called energy. Okay, very good. And its SI units. What is the SI units? Its SI unit is joule. Yes, SI unit is joule. CGS unit. Its CGS units erg. Yes, very good. Its CGS unit is erg. And also you can write their dimensional formula. Okay, dimensional formula of energy. What is? You know the energy is equivalent work. Very good. Energy equivalent work, and work can be write force into displacement. Very good. And you force you can write mass into accelerations. Okay, acceleration and into displacement, this you can write. What is the mass we measure in kg. Very good. Acceleration meter per second square and displacement meter. So you will write kg meter square s minus 2. Okay, or you will convert this one in dimensional formula. So you will kg for m for l, s for t, and power will remain same. So this is the dimensional formula of energy. Okay, and another, the types of energy. Types of energy. What is the types of energy? You gave examples. Yes, types of energy. First, like mechanical energy. Next, heat energy. Okay, heat energy. Next, light energy. Okay, there are so many types of energy that is divided. It means you will write their definitions, SI unit, CGS units, dimensional formula, and the types of the energy. Okay, the kinetic energy also you can take. Okay, so these are the types of the energy, many types of energy. Whenever you will see the work energy and powers and related, that you will know. Okay, students. So I think that you should write these topics, that is the energy definitions And now we will discuss about their types. One more is the kinetic energy. Okay, and we will also find out their formula. So I think that all you have written. Okay, very good. Now come to the points. We have next topic, that is the kinetic energy. Kinetic energy. What is the kinetic energy? Kinetic energy means what? The energy that is developed by objects when it in the motion, or you can also say that it is the the energy developed by object due to virtue of its motion. That can also you write. Okay, very good. So you will write it is the energy developed by virtue of its motion of the object is called kinetic energy. Okay, is called kinetic energy, and you know that it is denoted by K is equal to half mv square. Yes, K is equal to half mv square. The energy, that means the kinetic energy, can be denoted. Now, how you will find out their formula? You see that suppose we have here an object here and having mass m. M is the mass of the object, and at point A the object it is at rest. So u equal to what? 0. U will 0. But whenever you will give the force, the object will move from, suppose that A to B. Yes. Okay, and it having the velocity v. Okay, and s is the displacement. Covered by object. So you know that you can write, yes, what is the s? S is the displacement. Yes, displacement covered by object. M equal to mass of object. Okay, and another you can also write here, v is velocity. Okay, v is velocity, F equal to force. Okay, so we have formula. You know that whenever it will move from one point to another, so it will, the work done by the object means, now work done by object. What will be the work done by object? You know that work equal to force into displacement. Yes, formula we have, work equal to force into displacement. Okay, so this you can write here, W is equal to F dot S also you can write, and also you can write F. If you will remove this vector sign, so here will be F has cos theta, because here is the dot product, and you know you will take theta is equal to 0 degree. Okay, very good. So 0 degree, that means the cos 0 means 1. So you put here, so W is equal to Fs into 1 means W is equal to Fs. So you got the work done. But you know that formula, since force equal to mass into accelerations, so or you can write MAS, can we write? Okay, very good. But you also know that since v square minus u square is equal to 2as, since u equal to 0, okay, initial velocity is 0, so v square minus 0 square is equal to 2as. So therefore s equal to v square by 2a, and this value you can substitute. Therefore w equal to what you write, ma into v square by 2a, and this a and a will cancel out, and finally you have w is equal to mv square by 2. It means w equal to half mv square, and you know that w equal to Ke. W is equal to Ke, that is the kinetic energy, and this you can write also. So here will be Ke equal to half mv squares. So this is the this is the formula of kinetic energy we got, simply. But you know that this is for the class 9th students, they will write this ones, and in the class senior, that is the 11th, you will know the calculus methods. Which methods? Calculus methods. Very good. So I think that you should write these ones, or you can take captures. And another, this is the later methods. Another methods you can use also. So shall it erase? Yes. Very good. Now you see, if you will take the another method, then you will take the work done equal to a small amount of work done. Now you will take now a small amount. Now it will be same. Now a small amount of work done. What is the work done? Force into displacement. Same you will take, that is the work equal to that you will take. And same process you will take here. It means dw, a small you will take, no? So dw is equal to f ds, and here will also, but if you will remove this vector sign, so here will be same, that is the dw is equal to f ds. Why? Because theta is equal to 0 and cos 0 is equal to 1. So you will multiply, then you will get same. And also you have formula, since you have f is equal to ma, then put here dw, yes, dw equal to what you will write? ma ds. Can we write? Very good. And what you can write? A, since you have a equal to dv by dt, rate of change of velocity with respect to time. So put here. So you will write dw is equal to ma dv by dt into ds. Can we exchange their positions? This place you can exchange. So dw is equal to m ds by dt, and dv you can write here this. Why? Because we know that v is equal to ds by dt. Velocity is equal to rate of change of displacement with respect to time. That's why we can write here, means dw is equal to m v and dv. This you can write. So you got the small amount of work done. Suppose the object moves any 2 points, you can take suppose that T and Q. T and Q means the object here. On that case, you can find out this is the ds displacement. But you will find out the total amount of work done. Then you will integrate these ones. Now integrating. So you will integrating. Integrating it. So integrate, you know the formula, w is equal to integration of dw. So w is equal to integration. What is the value of dw? mv or dv. And here is the limit. This is the velocity. So velocity start from 0 to v. You will take 0 to v. Now this is the constant. So you will write w equal to m is constant, and integrate this one. So v dv, that is the v square by 2. V square by 2, and 0 to v you write down. Half you can take common. So here will be half m, and then here v square 0 to v. So w is equal to half m. You will put upper limit minus lower limit. So here will be v square minus 0 square. V square minus 0, because power is 2, So multiply this one. So w is equal to half m v square minus half. But how you will take this ones? You see that in this case, in the calculus, I think that you will put here not the 0 to u, because the is what you will take that same process. Multiply, no problem. If you will multiply, then what will be here? Half m into 0. So w is equal to half m v square, means w is equal to half m v square. This is the amount of work done. But you know that what will happen, as usual before we have done, the work done and the kinetic energy or energy is equivalent. So you can write W is equal to KE. Therefore, you can write KE is equal to half mv square. So this is the second method, okay, by the calculus. Okay, students. So what the methods I have solved here, you should practice. I think that all you have understood these questions, and those who have not subscribed, please subscribe my channels. Also like it. Okay, thank you, students. So next class we will discuss more questions. Okay, thank you.